This is the review that you guys received on Friday, November 30th. That was supposed to be due this Wednesday, the day of the test. Um, I recorded a video doing the whole thing. It took an hour and 10 minutes on Friday, but I didn't have any space left on my computer, so it didn't save the video. So because of that, I learned my lesson, and I'm going to do this in two parts, so it's not as long. So in case there's not enough space for that long of a video, it'll all be there. Also, we'll see if I go at the same pace, because I thought I explained things really well in that video, but I'm probably a little frustrated that I have to do this again. So we'll see how it goes if it takes that long again, but it'll be in two parts. Right? One for each page of this. So number 1 through 6, they're asking us to classify each triangle, choose all that apply. So we have 3 different ways to classify triangles by sides. We can, first of all, let's get rid of congruent there. We have 3 different ways. If 2 sides are the same, they're isosceles. So 2 sides are the same. If all sides are the same, all sides are equal, 2 sides are equal. And then let's put H, scalene. Okay, no sides are equal. So if we have a scalene triangle, all the sides are different lengths. None of the sides are the same length as the other sides. If we have equilateral, all the sides are the same length. If we have isosceles, 2 of the sides are the same length. Okay, then we can classify by angles. So these are classifications by sides. These are classifications by angles. A right triangle has a right angle. An acute triangle has 3 acute angles. Okay, an obtuse triangle has 1 obtuse angle. Okay, meaning the other 2 are then going to be acute. So an obtuse triangle has 2 acute angles and 1 obtuse angle. An acute triangle has 3 acute angles. Right triangle is going to have 1 right angle, then 2 acute angles. Because if one of the angles is right, it's 90 degrees, and therefore the other 2 are going to add up to 90. So neither one can be obtuse. An equal angular, all the angles are the same. So let's look at number 1. We have 2 sides that are described as being length A, and 1 side is described as being length B. So since 2 sides are the same length, this is isosceles. We then notice we have a 3 acute angles. Okay. So since we have 3 acute angles, we are going to have an acute triangle. So we have an isosceles acute triangle. Okay, number 2. We have angles 35, 25, and 120. Since one of the angles is greater than 90, one of the angles is obtuse, right? So if we had a right angle, this would be 90. So since it's 120, it's greater than 90. Since this angle is greater than 90, it's an obtuse angle. Since we have 1 obtuse angle, we have an obtuse triangle. In terms of the sides, right, since all these angles are different angle measures, all the sides are going to be different lengths. So we're going to have a scalene triangle, so it's going to be a scalene obtuse triangle, right? Since all the angles are, right, we talked about how the longest side is opposite the largest angle. So this is the longest side because it's opposite the longest angle, right? The shortest side is opposite the shortest angle. Okay, so since all the angle measures are different, we know all the sides are going to be different lengths. So we know we have a scalene triangle. Here we have two sides that are the same length. So if we have two sides that are the same length, it's going to be isosceles. Okay, and then we notice we have three acute angles. So this is isosceles acute. Number 4, we notice angle C is a 90-degree angle. It's a right angle, so it's 90 degrees. Okay, if we do our triangle sum theorem, we know the measure of angle A plus 38 plus 90 is going to equal 180. So the measure of angle A plus 128 equals 180 minus 128. The measure of angle A is going to be 52. Since all the angles are different length, different measures, right? All these sides are going to be different lengths. The longest side is going to be AB, the shortest side is going to be AC, right? And then the side in the middle is going to be BC. So since all the sides are different lengths, we know it's scalene, right? All the angles are different measures, therefore we know all the sides are different lengths, and since the sides are different lengths, it's going to be scalene. Then again, since we have a right angle, it is a right triangle. The definition of a right triangle is a triangle with a right angle. So we have a scalene right triangle. I can already tell my enthusiasm is not as much as it was on Friday. I did it kind of mad. That was a great video. And I just didn't have enough space. So here we have three angles that are the same, right? These arcs are telling us each angle is congruent. So all the angles, since all the angles are congruent, their angle measures are the same. Since all the angle measures are the same, we have an equiangular triangle. Okay. Again, as we said before, if we have equal angular triangles, we have equal lateral triangles. So if all the angles are the same, all the angles are the same, all the sides are going to be the same. So we also have equilateral. Right, lateral, it means sides. So if you're moving laterally, you're moving side to side. So equilateral, equal sides, equal angular, equal angles. If you put acute would also be an accurate description of this triangle. Right, since we have an equiangular triangle and all three angles add up to 180, we know we would have 60, 60, and 60. Right, we've done that several times. An equiangular triangle has angle measures of 60, 60, and 60. The next one, again, 30, 70, 80. So all three sides are different measures. Therefore, all three angles are different measures. Therefore, all three sides are going to be different lengths. Therefore, we're going to have a scalene triangle. Okay, and we notice 30, 80, and 70 are all less than 90, so those are all acute angles. So since we have three acute angles, we have an acute triangle. So scalene, acute triangle. Scalene, acute triangle. So three ways to classify by sides. If all the sides are the same, it's equilateral. If two of the sides are the same, it's isosceles. If all the sides are different, it's going to be scalene. Okay. 4 ways to classify by angles. So we have, if all the angles are the same, it's equiangular. And then again, we have right, acute, and obtuse. So if we have a right angle, it's a right triangle. If we have 3 acute angles, it's an acute triangle. If we only have 2 acute angles and 1 obtuse angle, it's going to be an obtuse triangle. So you just need 1 obtuse angle to make it an obtuse triangle. Right? A triangle can't have 2 obtuse angles because an obtuse angle is greater than 90. So a triangle with 2 angles greater than 90 would have an angle total sum of more than 180. So you can't have 2 obtuse angles, just like you can't have 2 right angles, because then the third angle would be 0. The measure of the third angle would be 0. Okay, they're asking for the remote interior angles of angle 4. So again, this is regarding the exterior angle theorem, right? Our exterior angle equals the remote 2 interior angles added together. So angle 1 and angle 2, or angle A and angle C. It got named them both ways. So again, just an example problem. If you had 3x plus 5, 2x plus 1, and 15. Right, 3x plus 5 would equal 2x plus 1 plus 15. The exterior angle of the triangle, angle CBD, is going to equal the measure of the two remote interior angles added together. So 2x plus 1 plus 15, right? Then you would solve for x. Okay. We can do it, I guess. 3x plus 5, 2x plus 16, minus 2x. X plus 5 equals 16 minus 5. X is going to be 11. Number 8. So vertex is R, base angles are angle P and angle Q. So vertex is angle R, base angles are angle P and angle Q. Right? The base angles of the triangle are the two angles of the isosceles. This is an isosceles triangle. So we're talking about here is an isosceles triangle. PR is congruent to QR, so we have an isosceles triangle. So the base angles are congruent. So angle P and angle Q are the two sides that are opposite the congruent sides. They're opposite the sides with the same length. So we know they're going to be congruent, and we call those the base angles. And the other angle is called the vertex angle. That, again, is for isosceles triangles. We didn't really talk too much about that nomenclature. But base angles and vertex. And the base angles are the congruent angles in the isosceles triangle. Find each requested value. So ABC is equilateral. Okay, it's kind of cut off, but find the length of, let's say, AC. Okay. So we have an equilateral triangle. So an equilateral triangle, as we mentioned in the first part, was a triangle where all the sides are the same length. So AB is congruent to BC, which is congruent to AC. Since all the sides are the same length, we can just pick two sides and set them equal to each other. So 6x plus 3 equals 10x minus 5. Let me do it up here so I have more room. Okay. Subtract 6x from both sides. 3 is going to be 4x minus 5. Add 5. 8 is 4x divided by 4. 2 is x. So if we want to find AC, we know AC is going to equal 10x minus 5. 10 times 2 minus 5, 20 minus 5 gives us 15. AC is 15, and that better be what all the other sides are. 2 times 6 is 12. 12 plus 3 is 15. 7.5 times 2 is going to be 15 as well. So 15, 15, and 15. Okay, number 10, we have angle E is congruent to angle F. So by the converse to the isosceles triangle theorem, we can determine that DF is congruent to ED. So the converse to the isosceles triangle theorem says if the base angles are congruent, right? If two angles of a triangle are congruent, then the opposite sides are going to be the same length. They're going to be congruent. So if the measure of these two angles are the same, then the length of the opposite sides are going to be the same. Okay, so 1 is going to be equal to 3x plus 4. So we minus 4 from both sides. We get negative 3 equals 3x. Divide by 3. Negative 1 equals x. Right? And again, you can't have a negative length, but you can have a negative x value. So it's perfectly okay for that x value to be negative as long as the length is positive. And we know the length should be equal to 1. So if we plug it in, if we substitute it in, 3 times negative 1 plus 4, it gives us negative 3 plus 4, which gives us 1. Right? And we know both those sides should be 1. Okay, number 11. Find the measure of angle 1 and the measure of angle 2. So they're giving us this angle is 120 degrees. Okay, so we notice these angles form a linear pair. So 180 minus 120 is going to be 60. So we know this angle is 60. We have a right angle here, so we know this angle is 90. And we can use the triangle sum theorem to find the measure of angle 1. And we know the measure of angle 1 plus 60 plus 90 is going to equal 180. The three interior angles of a triangle are going to add up to 180. So the measure of angle 1 plus 60 plus 90 is 180. So the measure of angle 1 plus 150 equals 180. Minus 150 from both sides. The measure of angle 1 is going to be 30 degrees. Okay, so this one is going to be 30 degrees. Sorry, it's pretty small, but right. So we got 180 minus 120 gave us 60. This is the right angle, so we know it's 90. And then we solve this one to be 30. Okay. Vertical angles. So this one is going to be 60. We have an isosceles triangle. So if this is 60, this is also going to be 60. And then here we have a linear pair, so 180. I am tired, that's why I'm writing so sloppy. 180 minus 60 is going to give us 120. Right? These are a linear pair, which means they're supplementary, so their angle measures add up to 180. Answer the questions about corresponding parts of congruent triangles. So we have triangle TGS is congruent to triangle KEL. Which angle in triangle KEL corresponds to angle T? So right away, just by the name, we know it's going to be angle K because it would come in the first of both names. Right, and again, if we want to draw this out, we have TGS and KEL. We know all the pieces here are going to be congruent because they're congruent triangles. Okay, so what's congruent with angle T? It's going to be angle. Okay. We know that from the name. Triangle TGS is congruent to triangle KEL. Which segment in triangle TGS corresponds to EK? Well, here's EK. What's going to correspond with EK? It's going to be GT. It's going to be GT. Right? So EK, middle to first. So GT, middle to first. So it's going to be GT. Right? On the same order in the second one as you did in the first one. We make these a little bigger. So 14. We got to write a congruent statement for the triangles. And it's cut off a little bit. We got to write a congruent statement. So they're giving us right angles. Angle M and angle G are right angles, so we know right angles are congruent. So we know angle M is congruent to angle G. Okay. We know HN is congruent to HN by the reflexive property, or we could say HN is congruent to NH by the symmetric property. And we know MN is parallel to HG. Okay. By these arrows, that's what the arrows signify. So when we have parallel lines, we should look for alternate interior angles. So here's our parallel lines. Here's our parallel lines. Here's our transversal. Okay, where's our alternate interior angles? Right here. Right, some of you will make the mistake. You'll say angle HNG is congruent to angle NHM. Okay, but these are only congruent if the lines are parallel, right? The alternate interior angle theorem says if the lines are parallel, then the alternate interior angles are congruent. So if the lines are parallel, so MN is parallel to HG, then we can say our alternate interior angles are congruent. If it did not say the lines were parallel, we still have alternate interior angles, but we don't know that those alternate interior angles are congruent. So we know these angles, angle GHN and angle MNH, are congruent. These are alternate interior angles, but since we don't know if H and NG are parallel, we can't say that those are congruent. So let me erase the lines and put it back in so we can see our triangles. So we have a right angle, we have a shared side, then we have an alternate interior angle. So cover one triangle up. We have angle, angle, side. So by angle, angle, side, we can say triangle. Again, first one doesn't matter. We can pick the first one in whatever order we want. So let's say GHN. So what's the corresponding piece to G? The corresponding piece to G is going to be M. What's the corresponding piece to H? It's going to be N. Okay, and then what's the corresponding piece to N? It's going to be H. Okay. So if this is confusing, imagine pulling this piece off and then rotating it. So if we pulled this piece off the triangle and then rotated the N around, we would get something like this. So this N gets rotated right down here. Okay, rotate this N down here. Our right angle is at M. So again, rotate it. And H is going to pop up here. So we have H, M, and N. So what corresponds? Again, let's erase this. What corresponds with G? M. What corresponds with H? It's going to be N. Okay. What corresponds with N? It's going to be H. So G, H, N is congruent to M, N, H. G, H, N, M, N, H. G, H, N, M, N, H. Okay. And again, you could have named this first one 6 different ways. So there's 5 other ways to name this. We could have named it triangle GNH, triangle HGN, triangle HNG, triangle NGH, triangle NHG. Any one of those ways would have worked, but then we would have to match up the other one congruent. So let's just say we name this NH or NGH. Then we would have had to say that's congruent to triangle. And what corresponds with N? Well, it's going to be H, right? What corresponds with N? Well, N on this one would be H. What corresponds with G? M. So H, G. Oh, M, I'm sorry. So even now I'm getting confused. Right, so here's N. So if we look at this triangle, right, we flip this one around. So let's look at just this triangle right here. So N, what corresponds with N? H. What corresponds with G? M. what corresponds with H? N. So NGH is congruent to HMN. Number 15, based on your answer to the last question, what segment is congruent to NG? So NG, last and then first. So NG is going to be congruent to, so NG, so that's going to be congruent to HM. Last and then first. Last and then first. NG, HM. If you look at this one, NG is congruent to HM. Right? So no matter how you named it, you're going to get the same answer for 15. As long as you named the other triangle in the same order. Okay. 16. What are the congruent triangles in the diagram? So we have side, side, side. So by side, 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 we know the triangles are congruent. So let's name our congruent triangles. Again, let's pick one. ABE. What's the corresponding part to A? So A is between the hash marks 1 and 2. So what's between the hash marks 1 and 2? It's going to be C. B is the vertex here. Okay, so B is between the 1 hash mark and the 3rd hash mark. So between the 1 and the 3rd is going to also be B. So this one's also B. And then E is going to correspond with D. So E is between the 2 and the 3. So D is also going to be between the 2 and the 3. Okay, and again, you could have named this however you wanted. There's 6 different ways, so there's 5 other possibilities. If we named it EBA, or let's say, yeah, EBA. So E corresponds with D. B corresponds with B. A corresponds with C. So 6 different possibilities to have there, as long as your second triangle matches up with the corresponding parts of your first triangle. All right, EB is congruent to DB. Okay, EA is congruent to EA is congruent to DC, and BA is congruent to DC. Same order, corresponding parts all match up. 17. The rhombus, QRST, is made of 2 congruent triangles, isosceles triangles, and we are given that the measure of angle QRS is 34. What is the measure of angle S, we could say? What's the measure of angle S? So we have 2 congruent triangles, right? It's telling us these triangles are congruent. So if the triangles are congruent, first off, let's show which 2 triangles are congruent, and then we can proceed from there. Okay, so we know QT is going to be congruent to RS, and TS is going to be congruent to QR. Okay, we also have a shared side. Okay. So we know by the reflexive property that RT is congruent to RT, or by symmetric RT is congruent to TR. So by side, 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 we know triangle. You can name it whatever you want. QR, well, not whatever you want, but however you want, whatever order you want QR and T to be in. let's just say QRT. That's going to be congruent to triangle. So what's the corresponding piece to Q? It's going to be S, so between the 1 and the 2, S. R is between the 2 and the 3. So here between the 2 and the 3 is T. Okay. And then T is between 1 and 3. So between 1 and 3, we're going to have R. So again, 5 other ways we could have done this. We know QR, we know again, this is going to be 34. And we know this is going to be 34. Well, we wanted those two angles to be congruent. So let's scratch that. Let's go back. Let's go back. Start this problem over. Okay. Let's say QR is congruent to RS, because it is. And then our second pair is going to be ST and QT. Okay. So we have two pairs of congruent sides. Okay. So our third, we have a shared side. Okay, so our third corresponding part that's congruent is RT. RT is congruent to RT by the reflexive property. Since we have three corresponding sides that are congruent, we can say triangle. And again, we can name any of the 3 points in any order. Okay, QRT. Okay, we're going to say that's congruent to the triangle. So we have QRT. So the corresponding piece to Q is going to be S between the 1 and the 2. So the corresponding piece between for R then is going to be R, right? Between the 1 and the 3 is going to be R, and then between the 1 and 3 is also going to be R. And then corresponding to T is going to be T, right? Between the 2 and the 3, and the 2 and the 3 is going to be T. So we know the triangles are congruent. So we know this angle QR, so QRT, angle QRT is going to be congruent to angle SRT. So we know the measure of angle QRT is going to equal the measure of angle SRT. Since the angle measures are the same, we know since the whole thing is 34, right? Angle QRS is 34. And we know these two are the same. We know that the only possibility for them to be is 17, right? We have to split 34 into two congruent pieces, right? So the measure of angle, if we want to be more formal, we would say the measure of angle QRS is going to equal the measure of angle QRT plus the measure of, I'm making this too complicated, I think, SRT. What do we know QRT? Well, we know SRT equals QRT. So it's going to equal the measure of angle QRT plus the measure of angle QRT, which is going to equal 2 times the measure of angle QRT. Right? QRS is 34. Then we divide by 2. 17 is going to equal the measure of angle QRT. Basically, what we're saying is since these two angles are the same, we divide 34 by 2, and we get 17 for each angle. Since we have isosceles triangles, this is going to be 17. And then we can find the measure of angle S by doing 180 minus 17 minus 17, which is minus 34, which gives us 146. So this is 146. All right, the other way again, measure of angle S plus 17 equals 180. Okay, measure of angle 5 plus 34 equals 180 minus 34, minus 34. Measure of angle 5 is S. I'm sorry, measure of angle S is 146. Okay, simple. Let's go back. Okay, these triangles are congruent, right? So we know isosceles triangles, so these angles are congruent. Okay. We know this angle is congruent and that angle is congruent. Okay, this whole thing's 34, so it's 17 and 17, so that's 17. And then we can find the measure of angle S. Definitely overcomplicated that one. But that's the last problem on there. So that's part 1. I will do part 2 right after this. And the reason, again, is just so I don't have longer videos.